This will be about dividing polynomials, specifically example 4 and 5 from section 6.2. So example 4 is negative 12, a to the 5th b to the 2nd over 8ab to the 2nd. So these numbers out front are going to act differently than what we do with the exponents. We kind of take each grouping and work with it on its own. So with the numbers out front, that is a fraction. Negative 12 over 8 is a fraction that we want to reduce. We can't actually divide 12 by 8, but we can look for things that divide into 12 and also divide into 8. Well, those are both even, so 2 would definitely work. We do want to try and find the biggest one, though, so there's actually one that's bigger. 4 would divide into both of these. I'm going to show you what would happen if you did pick the smaller one, though. If I divide both of those by 2, I would get negative 6 over 4. I would have to check again, and you should always check just in case you didn't pick the biggest one. So checking again, I would say, okay, what divides into both of these? Well, they're both even numbers again, so they both divide by 2. So that would give me negative 3 over 2. With the variables, first on this bottom variable, we need an exponent. If there is nothing written in, we use a 1. So the rule says when you're dividing and they have the same base, they both are a's, we subtract the exponents. We're going to do a to the 5 minus 1. When you do this rule, whatever you end up with is always on the top of the fraction bar. So a to the 4th would be on the top of the fraction. b2 over b2, they both have exponents, so we can go straight to the subtracting. 2 minus 2 is 0. When it becomes a 0, it cancels out and disappears when the exponent becomes a 0. So then our final answer would be negative 3a to the 4th over 2. Question 5 states 3ab over 9a squared b squared. So again, we kind of do piece by piece. 3 over 9 would go together because they're just regular numbers. A over a squared would go together because they're both a's, and b over b squared would go together. So 3 over 9, we decide again what divides into both 3 and into 9. Well, that would be a 3. If there's nothing that divides into both of them, you would just leave it the same. 3 divided by 3 is 1. 9 divided by 3 is 3. So a to the 1st over a squared. Remember, when there's nothing written in, we use a 1. So we're subtracting 1 minus 2, which gives us negative 1. That's going to be a problem, but we're going to take care of it in a minute. Same thing with the b's. It has the invisible 1, so 1 minus 2 again would be negative 1. So when you do this subtraction and the answer comes out negative, both of these have negative exponents, that actually means it moves to the bottom. So the top still has that 1, that's not going to disappear because you have to have the top of a fraction. A to the negative 1, it's going to move to the bottom, and it makes the exponent positive. So this would be 1 over 3, a to the 1st, b to the 1st. You do not have to leave the exponent on when it's a 1. You could write it as 1 over 3ab. Now this particular problem, you do actually have a second option to see why these end up in the bottom. If I have 3ab over 9a squared b squared, I'm going to break the variables down and say A times A, B times B. And you can see now A and A would cancel, B and B would cancel. We would still reduce our fraction by dividing each number by 3. So 3 divided by 3 still leaves us with the 1. 9 divided by 3 leaves us with a 3. Again, same answer. I was just showing you a second way that you could do it if those negative exponents are confusing for you.
It says grade 10, even though it's part of the same school year, is she grade 10 in terms of